spaCy is the library which will help me to do the pre-processing task, but spaCy can understand the inherent meaning, whereas NLTK just does the process in a very crisp manner. It does it very without understanding the inherent meaning, whereas spaCy tries to understand the inherent meaning, but it is slower when compared to NLTK. So here I say spaCy.load, and here I specify the language that it is working with. So here I specify that it is English. I pass a sentence. Apple is looking at buying UK startup for $1 billion, and here it prints the word part of speech tagging and the dependency. So now here apple is a proper noun, is auxiliary, and looking is a verb, and so these are certain part of speech tagging that is there. Now let's say here it has seen that apple is not referring to the fruit apple, rather it is referring to the company apple. Similarly, let's say if I pass I ate an apple. So now here for apple it is showing me a noun but not a proper noun as seen earlier. See, here it was showing me proper noun. Here it is showing me a noun because it is understanding the inherent meaning and then it is doing the task. Similarly, the tokenization can also be done here in spaCy, as we are seeing already. Then part of speech tagging can also be included. Now under part of speech tagging, I can also include what will be the lemma, what will be the tag here, tag for the part of speech tagging, what is the syntactic dependency, shape as in capital letter, small letter, what is it, and then is it an alphabet or is it a stop word. See, for is it is showing that it is an alphabet but it is also a stop word. So here this is that is I can get to know the complete details about the word. I can also understand here what will be the named entity recognition. Now what does this named entity recognition do is it will give me whatever are the nouns that are there. It will tell me to what category do they belong to. So here again, considering the same sentence, Apple is looking at buying UK startup Camille for $1 billion. So here we are using spaCy's named entity recognition to identify and classify various entities that we have, like names, locations, organizations, money, whatever it would be. So here I have four things. Apple, which is an organization. Then I have UK, which is GPE. Now GPE is nothing but geopolitical entity. Let me put this here. GPE is geopolitical entity. So it is showing me the location. Then Camille is taken as a person and $1 billion is taken as the money. So here what is it showing me apart from this is the start and the end character of these particular named entities. I can make use of various languages using spaCy. So here consider if I have words like dog, cat, banana, vector, and some other word. See here it is showing me that in this particular, MD refers to the medium model that is there. So it is indicating me if such a word has a vector in the medium model and what is the vector norm of it, normalization, and if it is out of vocabulary. So here this has vector. No, this particular word does not make any sense, so it does not have any vector in the large English language model. In the medium English language model. Vector norm, there is no value to it. And is it out of vocabulary? That in this medium model alone is it not included, but it is a valid word in English? No, it's not like that. That it is out of vocabulary and it is not included in this particular model. Using the spaCy library, I can also check on the similarity. So if I have two sentences like I like salty fries and hamburgers, fast food tastes very good. So these are the two sentences and I want to check what is the similarity. So it is 0.8. I can also check for the similarity between two words. Like for example, here I have taken salty fries. Okay, word number 2 and 3, salty fries, and between the fifth word, which is hamburgers. Now between these two words, see, salty fries, hamburgers. So between these two words, what is the similarity? It is 0.577. Let's say I like salty fries and gifts. So now here it is showing me I like salty fries and gifts. Fast food tastes very good. The similarity is 0.29 and the similarity between these two words is 0.22. Again, let me put it back and then you see this is the result, that 0.31 and here I have 0.289. So it understands the underlying meaning and then it tries to display the output. Now here I'm creating a pipeline within which I'm passing token to vector, tagger, parser, and this. So I load the small. SM refers to the small model, MD refers to the medium model, and LG refers to the large model. And here I'm passing a word which is I love coffee, and here so this particular word is in the small model. This is the representation of it. So if I look for the representation, it will give me the word back. So here I am referring to what is the representation of this particular word, and if I pass in the representation, I can get the word also. So let us look at consider a model, a sentence like I love French. Now for each and every word that is there, I am getting to know what is the, here I am seeing what is the hash ID of it. So this is basically the hash ID. So with the help of the hash ID, I'm getting the internal representation. And the next one is lexeme attributes. Now the lexeme attributes are nothing but So here, lexeme attributes. Lexeme attributes, it's showing me basically the lexical meaning of the word. So here I'm accessing the what is that word, what is its unique integer ID, which is nothing but the hash ID. Then what is the shape of it? Now shape of it is like capital, small. The first letter is capital here, so it shows capital. This next four are small, so it shows small. And then the next is it a prefix or not? Prefix or suffix, what kind of a word is it? Alphabet, prefix, and then the suffix. Prefix as in the first word. What is the suffix of it? Is it an alphabet? Yes, all these are alphabets. Is it a digit? False, false, false. It's not a digit. Is it a title? Yes, true is the title. These two are not the titles. Language, all these are in English. So like this I can work with the lexical meaning of the word. I can also make use of a pipeline. So here I am passing whatever I want in the pipeline. That is, in the pipeline I'll pass certain classes and I'll specify what and all do I need to be done. If I want anything to be excluded, that can also be done. So this is how I can implement pipeline. So let me show you a basic code implementing pipeline. So consider if I load the small model of our spaCy. I pass the custom component, that is, I define a function, custom component function, and within which I'm looking for the token and the part of speech. I'm adding this custom component after NER, after named entity recognition. So here let us see what happens here. So here these are the pipeline components. So this is inside the pipeline, that is inside the custom pipeline, token and the part of speech I pass here. This is what it shows. So after NER, I am adding custom component. If I want, I can add any other components also, like for example. So basically what is it showing me is after it does these token to vector, tagger, parser, attribute ruler, lemmatizer, and NER. It is applying this custom component. I can also define any other function that is there, and that will be applied. So for that same text, it will apply printing the tokens, and then it will show how will it print the entities. I think wait, I will just include this, Control X. Here I will include this. So here it will show me print entities. So here in the pipeline, I can specify how do I want. So this is the pipeline now, that it has included print tokens, because I specified first equal to true, last equal to true. Here it is showing print entities. And now when I execute this particular pipeline, here, see, this is print tokens. Okay, let me just put a print here inside print tokens component, and here also I can show print. Okay, so now this is inside print tokens, this is inside custom pipeline component, and this is print entities component. So this is the spaCy library, where it works a lot. It pre-processes and it shows me a lot of internal, it works with understanding the internal meaning as well. Then we also saw about pipeline, where we can include whatever functions we want along with it.